This is my brewery, and sometimes in life you just need to get a little bit vulnerable, pull back the curtain and expose everything. I'm going to take you through the journey of starting my brands, Holy Water and Swamp Water, and give you guys complete insight into the process and how this all began. I never grew up dreaming about owning a brewery. It kind of happened in early 2020. I was looking to start a product-based business. I had a friend come up to me and tell me about hard seltzer, alcoholic sparkling water, and how it was super popular in America. There's no sugar, no carbs, it was gluten-free. And to be honest, my relationship with beer was kind of getting a bit sour. I hated the way it made me feel, getting bloated after 2 beers, feeling lethargic. The problem was, in Australia, early 2020, you couldn't buy it anywhere. It didn't exist. I had zero brewing experience. And I'm a true believer in, if someone else can do it, why can't you? So I bought a 50-litre pilot system and started getting to work, coming up with all these different recipes, scouring the internet for ideas. And after 6 months, I finally got to a recipe I was happy with and gave me the confidence to hit the red button and order some tanks from overseas. Now, brewery equipment's expensive. I don't know why it is, and I encountered my first problem. I needed a big kettle to heat up my water and boil it. So I had a quick look online, and industrial kettles cost about $40,000. And I started thinking about it. It's literally just a stainless steel tub with heating elements in it. JP, why can't you build your own kettle? So it got me thinking, milk vats. They're stainless steel, they're used on farms, you can get big ones. And so I bought one for like $1,500. Bought some 3-phase heating elements, chucked those in, got an electrician in to come hook that up. And all in all, that probably cost me about 10 grand. So the brewery's about 70 square meters. And it's just the right amount of space for a kettle, 2 fermentation tanks, a bright tank, a canning machine, and a cold room. The basic process is everything gets heated up in the kettle, gets transferred to the fermentation tanks where the fermentation takes place, and then it gets pumped to the bright tank where everything gets carbonated, and then through into the canning machines. And so I got to work making drinks. First transfer. Nice and slow. One of the biggest problems I encountered was my canning machine setup. You see, the problem with canning lines is they're so expensive. We're talking $50,000 to $200,000. One of my options is to get a mobile canning service to come in and package all my drinks. That just increases the cost of my beverages an insane amount. So I thought the only way I'm gonna do this is if I have my own canning machine. It means I'll be in control, I'll be able to adjust things, I'll be able to can whenever I want. So I started to break it down. What is a canning machine essentially? And it's a very simple machine. It's just a bunch of solenoids controlled by like timers and sensors. So I thought, why don't I try build one? All right, so hear me out. This is my design for my 3 filling head canning machine. So the control panel will house all the electronics. It will send all the signals from there to the solenoids.
And I've got 3 filling heads. This is where the cans will be purged from CO2 and filled. Around the back of the machine, I've got 3 solenoids that will open and close for filling. And I've got an additional solenoid for the CO2, which will help purge the cans of oxygen before they're filled. So let's get to work.
I didn't know much about electronics and electrical engineering. I got a degree in civil engineering. But engineering is this wonderful world where every discipline is kind of similar at its core. And those 2 things are basic engineering principles and problem solving. I saw it as a challenge, an opportunity.
Okay, so over here is the linear actuator and the time delay for that. So once that goes off, it runs through a time delay to wait for the linear actuator, and then it has a time limit so that the cans are purged for only 5 seconds. We have the filling circuitry here. So these are liquid level controllers. So we kick off with the time delay to wait for the linear actuator, and then it kicks through.
My desk looked like an absolute mad scientist lab, but I was making progress, and the confidence started building. It came the day to test it, and I turned it on, and it started purging, and then filling. And I waited there in silence. And the filling stopped. And I did it. But then reality hit. So you see, the problem with the machine I built is it's an atmospheric filling machine. So what that means is it's pouring liquid into the cans with just the atmospheric pressure around it. The problem is my beverages are super carbonated. So what happens is there's not enough pressure on top of the liquid to keep the carbonation in. So essentially I was getting semi-carbonated cans. What I do need is a counter pressure machine. See, a counter pressure machine pressurizes the cans first and then pours, keeping a constant pressure on top of the liquid, which keeps that carbonation in. And so I did a bunch of research and I bought this bad boy. I didn't have a huge budget, so I bought this desktop counter pressure machine. And it was slow. I could only do about 2.5 cans per minute. It was taking me 2 days to can an entire tank. I slogged away on this machine, but it got me going and it got the product out there, and I slowly started building a customer base. I came to the realization that if I want to scale this business, I need something faster, more robust, something that's going to empower this business. And so I did a lot of research and I found this company, and they've been around for a while, and they had this counter pressure machine advertised for 5 to 12 cans per minute.
All right, JP, let me stop you there. So what I mean by cans per minute is how fast the can machine is. The higher the cans per minute, the faster the machine. And I'm aiming for about 8 to 12 cans per minute.
Well, that's perfect. I scraped together all the money I had and I ordered one. I was so excited, and it arrived. And I couldn't believe my eyes. It was beautiful. This machine was going to take my business to the next level. So I started doing some tests. And straight away, I noticed a few issues. There was software problems, and the machine was just spilling out CO2 for no reason. I did some investigating and I realized that the solenoid had been put on the wrong way around. And that's when the company told me I was the first person to ever own this model of machine. I was essentially the guinea pig. So I was determined to make this work. I really wanted to get this machine humming, and I waited a long time. I spent a lot of money. I just needed it to work. So I spent about 3 months with their engineers trying to update firmware, troubleshoot hardware, and I couldn't get the machine past 5 cans per minute. Whenever I tried to push it, I was getting underfills.
Just want to show you how inconsistent filling is, just based on weights. That's underfill, like way low. Underfill. So as soon as I go past 5 cans a minute, it just, everything, no matter what I do, filling's really inconsistent, and I can just, it just doesn't work. Underfill.
Sealed cans that I couldn't sell. But it got to the point where there was nothing I could do to get this machine up to 8 to 12 cans per minute. And I folded in and I sent the machine back. To be honest, it was quite a low point for me in this journey, but I didn't realize it would be a turning point. Okay, so the last canning machine didn't really work out. And I had to send it back. I had to start from scratch. But I realized I needed a simple machine, almost like a bare bones machine I could modify and improve myself. So I found this company in the States that makes this 4 filling head counter pressure machine. It uses stock parts, stock solenoids. Everything is kind of off the shelf that I could buy if I needed to fix things. And I watched some videos online and it got me really pumped, but there was one thing I noticed. It was a manual load. You see, someone had to be standing there loading 4 cans at a time every cycle. And that wasn't gonna cut it for me. I needed something semi-automatic. Okay, so I've got an idea here. See, in the side of the machine, I think we can cut a slot there, throw a conveyor up to it, and then the cans will automatically feed in to the in-feed tray. So I sent the company an email. Hey guys, I was just wondering, are you able to cut a slot in the side of the machine so I can add a conveyor? Yeah, that's actually a good idea. We've never thought about that. After a lot more questions, I ordered one. So when the machine arrived, I couldn't wait to test my conveyor idea. So I bought a cheap conveyor online, slide it up to the side of the opening. It was kind of make or break here. It didn't work. But I realized that I just needed some sort of support bar to align the cans. So I printed one, popped it in, and boom, it worked. So now I had a semi-automatic canning machine. So the goal with this machine was to reach maximum efficiency. I couldn't have 2 or 3 people running the machine. Ultimately, I wanted one person to run it. Okay, so there's 4 things that contribute to the efficiency of this canning machine. It's loading, monitoring, washing, and packing. And the longer these things take, the less cans per minute I'm gonna get out of the machine. So the goal is to automate as much as I can. One of the issues I discovered was the lid dropper. So what would happen is the cans would be too close together approaching the lid dropper. And it didn't give the lid dropper enough time, space, to properly drop the lids one by one. And to fix that, I printed a wheel spacer. It's like a big gear that when the cans pass through, it creates just the right amount of space for the cans to separate and let the lids drop on properly. Another one was a wash bay. I couldn't have someone spraying the tops of the cans and wiping them down before they put it on the pallet. That had to be automated. So I experimented with a couple of janky solutions and it seemed to work. So I went ahead and designed and printed a wash bay that washed the tops of the cans and then had an air amplifier that would blow the tops of the cans. Cans go through here, they get a lid, then they get seamed up there, and then they come through my little wash bay. That's pneumatic and works on this little switch here. So you'll just see, there we go. Just
just like a...
There's a couple of other things I added, like this can washer. It allows me to quickly wash any dirty cans. One of the most transformative additions to this machine was this tank head pressure regulator. See, without it, my CO2 tank was constantly pushing a certain amount of CO2 into my tank. But during the canning process, the tank fluctuates in temperature, meaning sometimes more CO2 gets absorbed or expelled from the solution, which was giving me inconsistent filling and sometimes super foamy pours. With the tank head pressure regulator, it essentially watches the pressure in the tank and adjusts accordingly, ensuring I have a constant head pressure, meaning every time the canning machine fills, the pours are super consistent. For packaging, I made a pneumatic press machine. This little thing here is a plastic 4-pack holder, but it's a problem. They're expensive, they're made out of plastic, no one recycles them. I think I've found a solution, but it's come with its own challenges. Let me show you. So I found these 4-pack holders. They're made from sugarcane, they're biodegradable, and they're way cheaper. But there's a problem. They're an absolute bitch to put onto the cans. Super slow, very tedious, really disruptive in the canning process. But I got an idea. I designed and printed a manual applicator that could put the 4-packs onto the cans. And this worked, but doing this on 500 4-packs over a canning session really got me fatigued. I ended up getting blisters on my hands. Ideally, I need something that can press an entire carton at once, 4 4-packs. So it got me thinking, what if I used compressed air to push the holders onto the 4-packs?
And that, JP, is called pneumatics. Imagine blowing up a balloon and letting it go. The escaping air moves the balloon. That's air pressure doing mechanical work. Pneumatics captures that principle, but controls it with valves, compressors, and actuators. So I got to work, designing a pneumatic press machine. So this is what I'm thinking. A compressor set at 90 psi sends air to an air regulator. That then sends it around through to a pneumatic press button, which then sends it to another one on the other side. Once those 2 buttons are pressed, it releases air into a pilot valve, which then passes it into a piston, pressing down the holders onto the cans. So let's get to work.
I started with 1 piston, but that failed miserably. So I upped it to 4. That didn't work either. Okay, so the 4 pistons isn't working, and I was convinced it was a problem with my mold, the way it was designed. So I literally went and made 8 different types of molds, thinking I wasn't distributing force in the right areas on the holders to get them on properly. But it's still not working. Then I remembered a basic physics principle. Force equals pressure times area. And I think I know where I messed up. I was considering the entire area of the base press plate. But that's not the effective area. The effective area is the base plate on the piston itself. My compressor's maxed out at 90 psi. So I went crazy on the pistons and added another 4 to make a total of 8. And guess what? It worked. So now I have a semi-automatic pneumatic press machine that can press an entire carton all at once. It saves me an insane amount of time, and it allows me to keep my brand's ethos of plastic sucks, let's get rid of it. But after doing a couple of runs, I realized that I didn't have enough cans on the line ready to go for me to manage everything else that I had to do on the machine.
One of the big issues for me was my cans would arrive on a pallet 14 layers high. So for me to get up to the top layer, I'd have to go up a ladder. Me going up and down a ladder the entire canning session wasted a lot of time. So I needed a solution. So I looked at a whole bunch of mainstream canning setups, and most of them had this thing called a depalletizer.
What's a depalletizer? It's supposed to make your life much easier. Just load the cans and let it feed right in. No hassle, just sit and watch the action.
All right, of course I'm gonna build my own depalletizer. I had a bunch of aluminium lying around, so I just used that for the frame. I hooked up a linear actuator to a ramp. I used a barbecue rotisserie motor to pull the cans in. 3D printed a chutes so the cans could feed into the conveyor nicely. I bought this cheap electric forklift, which was, to be honest, more of a pain than a blessing. I persevered, sorted it out, and it works just fine now.
What's a depalletizer? It's supposed to make your life much easier. Just load the cans and let it feed right in. No hassle, just sit and watch the action.
Did you see that? Let me show you again. I'm walking up and down a ladder still. Problem I was trying to solve kept on coming at me, and I could probably spend a bit more time working out this depalletizer. I actually had 3 different versions of it. I threw a conveyor up at the top. I thought that would feed it in. I made the cans go in sideways, and then I made this little twist that would upright the cans just before the conveyor. But I still ran into issues, and I was spending a lot of time monitoring the depalletizer instead of monitoring the canning machine. Then I had this epiphany. Now that I had this forklift, did I really need a depalletizer? Because what I could do now with the forklift, it's now easy for me to break the pallets down into 2 smaller chunks. All I needed now was an infeed table. An infeed table is like a big lazy Susan that's always rotating, and it slowly feeds in the cans into the conveyor. And it worked out I could get about 70 cans ready to go on the infeed table and the conveyors, which was more than enough time for me to manage a whole bunch of things before I had to add in more cans into the infeed table. So I decommissioned the depalletizer and I got to work.
Infeed table, spin around and make the line much stable. Like a lazy Susan, hypnotizing a beautiful fusion.
I could look back at these problems and challenges as a failure, but to me, they're a lesson learned. This whole journey has been my kryptonite and my fountain of knowledge. See, sometimes challenges in life are the only way we can grow and learn. The easy thing to do in these situations is to give up and move on. But sometimes we miss that opportunity in doing so. Sometimes
We just need to push a little bit harder and carry on going. We need that perseverance to get back up and find that light at the end of the tunnel. I called my alcohol brand Holy Water because I felt like hard seltzer was the holy grail of alcohol. There was no sugar, there was no carbs, it was gluten-free, it didn't make you feel terrible in the morning.
It's fresh like a flower, I'm feeling higher than a tower. Holy water's got me loving that new bubblegum grape sour. Sorry.
And the whole idea is to kind of take that craft brewery aspect of limited releases and bring that to the hard seltzer world.
Okay.
And I wanted to create an urban brand, something a bit edgy, something that kind of aligned with alternative sports. And I came up with this brand philosophy that Holy Water represents this sacred expression that we all have inside of us, the passion and creativity we all desire in the pursuit of connection and happiness. I sold my first Holy Water drink in November 2021. So it's been 3.5 years now. And over that time, it got me thinking about beverages that missed the mark for me. And one of them was sparkling water. I drink a lot of sparkling water, but none of the brands out there really resonate with me. They've all got the same messaging, the same branding. And I wanted a brand that spoke to me and spoke to people like me. And so I came up with the brand Swamp Water. Swamp Water is an acronym for sparkling water against manufactured plastic. And it's based around this comic I wrote almost 3 years ago where the world is this dystopian future because of single-use plastic. And I wanted to keep it really healthy, take inspiration from my brewery, Holy Water. I wanted to introduce botanicals into the sparkling water world. So Swamp Water is made from spring water. I've actually trucked it in. It's only made with botanicals, and it's a brand that I'm really excited about. I started working on the brand about a year ago, and in the last 4 months, I've released 2 flavors, lemon myrtle and motueka hop. At the moment, I'm on my own. I brew and package everything in Morningside, Brisbane. This whole journey has been a massive learning experience for me, and it's been a struggle at times. It's filled me with joy and happiness, but I love what I do. I really want to get these brands out to as many people as possible. So if you want to keep along the journey, please subscribe. I'm going to be bringing out a whole bunch of videos, and let's see where we can take these brands.